So my name is Viraj Janardhan Nosare from BTech CSE-AIML. So I am explaining the topic. Name is open source deep learning models. So let's go to the introductory part. So why we have choose this problem statement? So there's the thing is accessibility and collaboration. So firstly, it provides the free access and advanced AI tools in the ecosystem, and we also develops and enables the researchers and worldwide to share the things and improve the code to do and provide all over the access. So and simplifies the understanding and complex AI concepts through open documentations. Like there are examples like TensorFlow and PyTorch. What does the TensorFlow and PyTorch do? The TensorFlow and PyTorch are leading open source frameworks offering pre-trained models and easy development tools for the AI projects. So the next one, it's concept descriptions. Means what is the open source for deep learning models. So there are core features. There are three core features of it. The first one is provide pre-trained models. Why we had to choose the pre-trained models? The thing is for the faster implementations of the model training. So what it does? It does the flexibility and customize the retrained model for specific tasks. So and it encourages transparency and community driven important, and it maintains the privacy issues also. The best example for this is the Hugging Face transformers. What the Hugging Face transformers do? It is an open source transformer model and it is based on LLP tasks, and it is like text generation and sentiment analysis. Okay, and so this model simplifies AI development by allowing developers to use the state architecture with minimal coding. So going to the next part, it is the working mechanism. How this model works and what the basis of the model is. So there is a process flow for the model. So firstly, the important the basic part is we have to collect the data. And firstly, we have to clean the data and feed it to the model for the training. And the data should be clean and bin monitored. And it should be in supervised manner. So the second part is the model adjusts internal parameters like it does back propagations and some tasks like through multiple iterations to minimize the errors. Once trained, it can accurate predictions or classification on new data, and it divides the data in valid and a test data. So the best example is the image classification model, and the best thing is the convolutional neural network, means we call it as a CNN, that learns to identify objects like cats or cars for labeled images. So it processes image layer by layer, detecting features such as edges and color, and finally classifies the image into the categories. So, and this is the best example for this model. So, what the challenges we have to face while doing this? The first challenge is that when we do this task, we have the large data set and very high computation, and the data sets are like in not in where manner, some are in unsupervised. So it be complex to understand it, tune and deploy effectively. So what we do, that risk of biased inaccurate results if trained on poor quality data. And the best example for this is model bias. And a face recognition model trained on limited demographic data may fail to detect face accurately for underrepresented groups. And AI systems are also deployed for the open sources. It can also reduce the fairness and the reliability. So, next part is the summary. What we have to take from this thing, and I have mentioned in the 3 points that we have to encourage open collaboration. We have to deploy the open source model on the over the internet. Like we have to access the research, learning, and real world applications. And what we face the challenges like data quality, bias, and high computational requirements. And the best example is we are using currently is like all are included in it like ChatGPT and also birth. And the best example is YOLO, that it is a written model. We can follow any data type of on this model. So we have enabled breakthroughs in natural language processing, computer vision, and automation. This model demonstrates how open collaboration and shared innovation can accelerate global progress. Thank you.